So here's the second part, E through H. The first one is super easy, so let's jump right into it. Here we got lithium metal, so that's just Li. Is strongly heated in nitrogen gas, that's N2. Strongly heated in nitrogen gas means that these two combine. That means lithium ends up being a +1, Li with a +1, and N has a -3, if you're looking. So that means that what I have here then, once you put them together, is Li3N, like that. That's it. That's all you have to do. Very simple. The next one is not quite so simple, and I need some room to do this. So let's take a look at F. So F is a combination of, here's boron trifluoride, and I noticed from the trifluoride that what I have here is a covalent compound, and that's important. And then ammonia gas. Now, like water, we should all be familiar with ammonia as NH3 because it's a simple formula and it comes up pretty often. And by this time in 2 years of chemistry, I'm hoping that you've seen ammonia before. I'm hoping that you remember that ammonium is NH4 with a +1. That's ammonium, that's the polyatomic ion, and ammonia is just one less H and no charge. So that's a compound just like H2O, CO2, like SO3, it's a compound. So here's what I have for F. To make this a little bit more obvious, we should take a look at the Lewis dot diagrams. So boron looks like this. I got 3 outside electrons, 1 on each side of boron. There's a 4th side here that's missing. Has no electrons. Boron has 3 valence electrons. Each of those 3 valence electrons is going to be connected to an extra electron from fluorine. So we got fluorine bonded to boron like this. And then I'm showing you the other 7, the other 6 electrons. So fluorine looks like this. It looks like there's 1 there, 2 there, 2 there, 2 there, like that. Here's where the boron and fluorine have a pair of electrons and form a bond. Okay, so there is no electrons there, which ends up being quite important, and here's why. Nitrogen now has, so nitrogen, if we're looking at the dot diagram for nitrogen has 5 valence electrons. So that means that I have one place that has a pair of electrons, which makes it more stable there, and then 3 single electrons, which is where the H's come in. So if I have this, I have 1, 2, 3. I'm going to get rid of this nitrogen up here to give myself some room. Hydrogen only has 1 electron, 1 electron, and 1 electron. So these all pair like that. And then you can see when we move these two together, now this is one of those things that is not easy to see unless it's pointed out, but these 2 electrons can actually form one bond. It's called a coordinate covalent bond when both electrons come from the same atom to form a bond with another atom. And that means that what we end up with then over here is a situation where I have B, F, F, F like this, and a bond between, and then nitrogen like this and like this. Now you can write this any way you want to. You can write it BF3 and H3 like that. Some people actually prefer to show that it's the B and the N that are together, which would be F3, BN, H3. Either one of these is good. So when I rewrite this then, I'm going to end up by doing this. I'm going to say, I'm just going to write it like this, BF3 and plus NH3 yields BF3NH3 like that. Okay, and here's why it happens down below. Okay, let's get rid of this so we can move on. I spent a lot of time on that one because I had to actually draw the stuff. So, oh, that didn't work. Sometimes I can just erase all of it. There we go, by circling in a touch. Sulfur trioxide gas is bubbled into a solution of sodium hydroxide. So sulfur trioxide looks like, this is letter G. Sulfur trioxide looks like this. bubbled into a solution of sodium hydroxide, like that. What happens on the other side? This is clearly going to have, we have issues of oxygen, and it looks like if I have two hydroxides like this, and one of those oxygens goes here, that's going to give me an SO4 with a -2. I know that's stable because that's a polyatomic ion, and the fact that the polyatomic ion exists means it's stable. What do I have if I have two OHs and take one oxygen away? Well, in case you weren't sure, you have two hydrogens and one oxygen. So it looks like on this side here, we have sulfate with a -2 and water as what's being produced. Now, what happens then to the sodium? Well, the sodium is a +1 on the left-hand side, and it ends up being a +1 on the right-hand side, which means, you guessed it, it's a polyatomic ion, which means that if I'm going to do this, I should probably go plus here and minus there. Now, we don't have to balance anything, but we do have to show what it looks like. The last one is actually pretty easy. I'm going to rush through it a little bit because this is a double displacement reaction. I got my lead 2, that's palladium, bonehead. I got my lead 2 nitrate, which looks like this, plus magnesium iodide. That's a +2, so I need 2 down here because that's a -1. And then on this side here, I got A, B, C, and D. So one of these is going to have to give off a solid or a gas, and it looks like my A and D there form a solid, plus, and then what we have left over is magnesium with a +2 and nitrate with a -1, so that gets a 2 here like that. Now here's the cool part about this. As soon as we form a solid, that means that we can get rid of these because these are spectator ions, like that and like that. So that means, as I come down here to finish up, that means for H, my answer would be PB with a +2 plus I with a -1 yields PbI2. That is a double displacement reaction, getting rid of, we formed a solid, it's a precipitation reaction, and we got rid of all the spectator ions. So that's it. All right, hope that wasn't too painful.